In the last lesson, you learned about endothermic and exothermic reactions, and you could predict which was one or the other based on the change in enthalpy of the reaction. So you might be wondering, how do we actually get these numbers in terms of calculating whether a reaction is exothermic or endothermic? Well, we use something called bond energies. So by the end of the lesson, you should be able to use bond energies to calculate the change in enthalpy of a reaction and determine whether it's exothermic or endothermic. So what's a bond energy? Well, a bond energy is the amount of energy required to break the bonds of 1 mole of a particular bond when both the reactants and the products are in their gaseous state. So these bond energies are actually average values. So looking at these three molecules, why do you think bond energies have average values? Okay, so the reason is because the energy required to break a bond depends on the environment the bond is in. So we have CH bonds here, 3 different CH bonds, but you notice this one has just hydrogens around it, this one has a chlorine, and this has a chlorine and a methyl group. So depending on the substituents bonded to this carbon here will affect the energy required to break that CH bond. So a chemical reaction is a combination of bond breaking and bond forming reactions. Bond breaking, from our last lesson, we learned has a positive change in enthalpy, endothermic, whereas bond forming is negative in terms of a change in enthalpy between the reactants and products, and that's exothermic. So you can calculate the change in enthalpy of a reaction using bond energies by 5 simple steps, which I'm going to go through in a worked example. The first step is you have to draw the balanced equation showing the structure of the molecules involved in the reaction. Step 2, you show all the bonds you would have to break to get the individual atoms. Step 3, show all the bonds you need to form to make these new products. Step 4, use the information that you will be provided with in the examination from a data table to write in the bond energies for each bond. And finally, in step 5, calculate the total energy using the equation. The change in enthalpy of a reaction equals the sum of the energy of the bonds broken minus the sum of the energy of the bonds formed. Okay, so it's basically the energy of the bonds broken minus the energy of the bonds formed. Okay, so now we're going to go through an example to calculate a change in reaction enthalpy to work out whether it's an exothermic or endothermic reaction. So the first step is to write down the equation in terms of all the bonds that are going to be broken and made. Okay, so you do pretty much an equation like step 1 where you show all the bonds that are occurring in the reaction. So in this particular example we have ethane going to reacting with chlorine gas to form chloroethane and hydrochloric gas. So step 1 is you draw out the equation with all the bonds. Step 2, you then list the bonds that are going to be broken. So in this case there will be 6 CH bonds broken from the reaction that you've just drawn, 1 carbon-carbon bond broken, and 1 chlorine-chlorine bond broken in order to form the products. Those are the bonds broken. In terms of bonds formed, you have 5 CH bonds formed, 1 carbon-chlorine bond formed, 1 carbon-carbon bond formed, and 1 hydrogen-chlorine bond formed. Next step is step 4, where you then, using the data table which you will always be given, you just simply multiply the numbers that you're given on the table. So for example, for CH bonds broken, you look across to the table here, you see that CH is 413, the bond energy. You have 6 of them, so this is why you multiply those by 6. So you continue on for each of the bonds until you get 2 totals. The sum of the energy for the bonds that are broken and the sum of the energy for the bonds that are formed. Finally, in step 5, once you've done that, the bonds broken, of course, you've calculated are 3,157 kilojoules per mole. The bonds formed are 3,272 kilojoules per mole. So then it's a simple calculation that the change in enthalpy of reaction will be the sum of the energy of the bonds broken here minus the sum of the energy of the bonds formed, which is here. So you do a simple subtraction and you get the answer minus 115 kilojoules per mole. And because it's negative, it's going to be a exothermic reaction. And that is how you use bond energies to calculate the enthalpy of a change in enthalpy of a reaction.